Building a powerful Gen AI chatbot with GraphRAG, combining vector search and graph knowledge with SurrealDB and LangChain. Introducing the next evolution of AI chatbots. Traditional chatbots often struggle with context and interconnected information. Today, we're exploring a revolutionary approach that combines the power of vector search with graph knowledge to create more intelligent, contextual AI responses. This is the story of GraphRAG, Graph Retrieval Augmented Generation. The challenge, beyond simple question answering. Imagine you're building a health symptoms chatbot. A user asks, "I have headache and feel nauseous. What could be causing this?" A basic chatbot might treat these as separate symptoms, but the real world is interconnected. Headaches and nausea often occur together, pointing to specific conditions, medications, or underlying causes that are best understood through their relationships. Enter GraphRAG, the perfect marriage of technologies. What makes GraphRAG special? GraphRAG represents the fusion of two powerful technologies. Vector search enables semantic similarity matching, finding relevant information even when exact keywords don't match. And graph knowledge captures relationships between entities, understanding how symptoms connect to conditions, treatments to outcomes, and causes to effects. The complete architecture, a 9-step journey. The diagram reveals the intricate dance between multiple components working in perfect harmony. Let's follow the numbered flow. The ingest phase, building the knowledge foundation. At the heart of our system lies the document, medical literature, symptom databases, treatment protocols. These documents flow into Ollama embeddings, where text is transformed into mathematical representations that capture semantic meaning. The storage layer, SurrealDB's dual power. The embeddings land in SurrealDB Vector Store, creating a searchable semantic index. Simultaneously, SurrealDB Graph maintains the relationships between medical entities, how symptoms connect to conditions, treatments to outcomes, and causes to effects. Real-world demo, the complete 9-step flow. Step 1, symptoms input. A user describes their condition. "I've been having persistent headaches, especially in the morning, along with dizziness and blurred vision." The chatbot receives this input and begins processing. Step 2, similarity search. The system performs a similarity search against the SurrealDB Vector Store, finding semantically similar symptom patterns and medical conditions based on the embedded representations. Step 3, vector search. SurrealDB executes this vector search, identifying the most relevant medical documents and symptom clusters that match the user's description. Step 4, find related documents. The chatbot retrieves related medical documents that provide context about the identified symptoms and their potential relationships. Step 5, generate query. Chat Ollama formulates a sophisticated query that will explore the graph relationships, asking questions like, what conditions commonly present with morning headaches and visual disturbances? Step 6, execute query. The SurrealDB Graph QA chain executes this query against the graph database, traversing relationships between symptoms, conditions, timing patterns, and demographic factors. Step 7, query graph. SurrealDB Graph returns not just isolated facts, but interconnected insights about how these symptoms relate to each other and to potential underlying conditions. Step 8, generate answer. Chat Ollama synthesizes the vector search results with the graph relationship data, creating a comprehensive response that considers both semantic similarity and medical relationships. Step 9, answer delivery. The user receives a contextually rich response that doesn't just list possibilities, but explains the interconnections. The combination of morning headaches with dizziness and blurred vision often indicates elevated intracranial pressure, which can be related to, and so on. The power of relationships. Traditional approach, headache to generic headache information. Dizziness, generic dizziness information. Blurred vision, generic vision information. GraphRAG approach, headache plus dizziness plus blurred vision plus morning timing equals hypertension pathway, connected to blood pressure medications, related to lifestyle factors, and linked to diagnostic recommendations. Technical implementation benefits. Enhanced accuracy. Graph relationships provide context that prevents misinterpretation of symptoms in isolation. Improved user experience. Responses feel more natural and comprehensive because they consider the interconnected nature of health information. Scalable knowledge. As new medical research emerges, relationships can be updated without rebuilding the entire system. Real-time learning. The system can identify new symptom patterns and relationships from user interactions. Beyond health, universal applications. While our demo focuses on health symptoms, this GraphRAG approach transforms any domain requiring contextual understanding. Legal document analysis with case law relationships, financial advisory with market interconnections, technical support with component dependencies, and educational content with concept relationships. The future of AI-powered applications. This integration of SurrealDB and LangChain represents more than just a technical achievement. It's a paradigm shift towards AI systems that understand context, relationships, and nuanced human needs. By combining vector search's semantic power with graph knowledge's relational intelligence, we're building chatbots that don't just answer questions, they understand the deeper connections that make their responses truly helpful. The purple gradient background in our visualization isn't just aesthetic. It represents the seamless blending of these technologies, creating something more powerful than the sum of its parts. This is the future of AI-powered applications, contextual, relational, and remarkably human in their understanding.